sessions will introduce the one of the idea, the concept, the how to creating the MEP loom, the modelings, a little bit effective way. So let you think after show these demonstrations. So basically, we need to have the component library for the each to figure out and configure those. So I just creating some examples of the library. So some machines or some the pipes, etc. So those can be the dead body or can be parametric models. So let's say dead body, it means it can be really fixed library that shape will not change, and the the component that can be changed. In this case, for example, the pipe length can be changed. So this should be a parametric model that length can be changed. In this case, for example, the other ones might be the dead body. But also, to use this in the skeleton level, we need to create, even dead body needs to create how we configure in the skeleton level. So, for example, I creating here the power copy, to represent of this object, and then this power copy register here in the power copy with the name. So this power copy can be used in the project that use the here the reuse of resource table. So you can add the resource name and the resource here that called the power copy, and you can set this from here. Let's see. So from here, that this power copy. So then you can use this local name in the script. Okay. So for now, for making easy to make, I didn't create the like this way. Instead of that, I just creating them in the just one level, creating the power copies here. So I will just show you. So each power copy just represent of the that object. You will see the name here. Okay, so this is just one of the examples how you're going to creating in the skeleton level. All some configurations, how it works, rotate or length. Maybe the fixed component don't have the length configurations, but maybe the rotations. So you have the rotation in this case, and you will always have the base location. So later on, the base location will be helping the instantiate the component in the product level. So it's named it here, and some another parameter to configure if this came from the chapter, or we need to creating as an adaptive component. So in that case, we're going to use the engineering template instead of a chapter. So here, and this is the end case of the adaptive case. So we have angle and sorry, not this one. This is fixed case. The adaptive case is this one, 5. So I will just hide and show where it is. Okay, here. So 5 and the 5 have the base locations with the adaptive true, which means you will going to use engineering template later. So this length parameters came from here. So whenever you change in skeleton, this will adapt, and the component, final component, will be having a same place with the location. Okay, so so this what is the simple template is. So I will show you the briefly how it works. So here's you have a access system, the location of the equipment. Then you selected equipment. So first time you have like that, and this equipment, for example, I want instantiate this equipment. So this is name. So just for now, just I use the simply the name of the component. So when you creating the name of the component, from here you will create the this component equipment here. After then, each in this case, this equipment have a lot of root, about the 5 things output, right? So just I select one of the access system for creating the next component. So we have the name here and some automation. So this automation is exactly the same as this automation. So when you put the name, it will be instantiated here. So let's create this element. So here I copy and I put it here. Then this will instantiate here. Then I want to rotate this in this case. So I rotate 90 degree. Okay, I think this is fine. Then this case you have a root one root instead. Unlike the equipment have a lot of root, but this case only one root or port, whatever. So I want to connect here another component. So I want to connect the this 5 street 5. So I put it here, the name. Then this will create the pipe here. So you can control the pipe, the length under here. Let's say 500, so 300, making shorter. And then now I will create here T. So here, let's try this one. So copy the name. And here, root 1. And put it the name here. And this automation will create it like this. Then now, maybe I want to create another street. So I will just copy this name because I already know. And the root, in this case, we have 2 different root here. Then I will select the first root and I put it here, the name, pipe name. Of course, you can put it here, pipe name. Then that means you will create another root here. So something like this. So all are connected and parametric. So this case, after I will just add one more elbow here. So I know the name of elbow, this one. I will just use this one here. So it should be here. Okay. Okay. Now that's fine. Of course, since this is the parametric model, so when you change the some parameters, for example, in this case, I will change another angle instead of 90. Of course, this will everything will follow. Right? Then here, what I did here, and maybe this whole geometry I want to put the same place here. So I can put here under here. In this time, instead of creating the name, but I will just copy and edit the access system, the location only. And when you update, then you will have that too. So if you want to connect, maybe you need to rotate this and you need to remove this and you need to stretch the length. So this kind of a concept. So you will easily creating the skeleton level. But this is just the one of the example. You can still use the some design table like connection between how the connection chart, if you can use the connection chart with the angles or whatever. Also, maybe you can use the UDF instead of the power copy. But there's several things you need to consider. Anyway, there's several way I can consider the how to configure in the skeleton level. Okay, so the thing is, once you define the automations and the skeleton level, how it works, then creating the component, I have a script here. So all the base location will found the name and it will be instantiated there. So in this case, with this access system, plus instantiate this component from the chapter. So when you look at the chapter, there's you have the list of chapters, and this chapter will be lead and the automations. Okay. So here I have the keyword to finding out which component it is. So I just use name as an item name and put it here as the same name for now. But maybe you have many different, the attribute you wanna mix all together. So let's come back to the project. So let's see the result. Then I select the finding out the location under the test. So click OK. Okay, now the components are instantiated here, so with the detail models. In my case, it's not so much detail though, so you can put it as more details stuff. So about the modifications, of course, this is the parametric, and each component are creating the engineer connections between the skeleton and the skeleton component. Right? So each component don't have any relations between. So all the modification should be done in the skeleton. So for example, now I want to change the distance here more. So 500. So this will be instant more here. So skeleton is changed, and maybe let's change the angle as well. So angle should be here, like 45 degree, right? And maybe also you wanna change the component, this one. But I will just show this first. It's a different process. So update the product level. So this will simply adapt what your skeleton you was working, right? So when you change the distance, this will adapt in everything because it's linked. So now let's change the component, replace the component here. Instead of replace here, replace means instead of replace the component, since it's a skeleton approach, I want to replace this part. So this is the level under here, right? So instead of I will create another part instead of this component. So let's select one of them. So this one. So I was this is not needed. So I'll just put this copy name of the component. And return here. So when you type here, so this will be instantiated. Then the next connections in the from here. So you only want to delete the T, but instead of that, this root 1 inside you want to keep it. So you want to copy this. I mean, move this this one. So and also change the input. So when you look at the input, this one, instead of this, you may wanna use this one. Then also you want to change the location under here. So this will continuously works, and then you can delete this one. That unnecessary. Okay. Then the thing is, for the I will change it also the angle here. 90. That's opposite. 180. Okay. Oh, sorry. Should be minus 90. Okay. So so skeleton is fixed, but for the component level, the simplest way is that I have a script to delete all the component, and the recreating it will be the simplest way. But if you have many components changed, that will be better. But just one component that you need to replace it, maybe needed to consider some another script or to change replace this component. But the thing is so in this component, let's see the product level. So this component is here, is no longer existing, so you can delete. Of course, when you delete, you have engineer connection will be deleted too. But here, this one, let's try to replace. So replace this by existing. Okay, and I select this one. So now, of course, the engineer connections will asking again because it's replaced. So I will select again this one to reconnect. Then when you update, so that's error. So I think it seems so while replacing the engine connection, all disappeared too. So maybe I will reconnect. This one is this one base and dash system here. Belt and then the location here. Base system, yeah, this one. Okay. Don't know. Yeah. So this is the way, just manually working. But maybe you might have another script. Some things change automatically, or for the update, or change the component. There's many things you can consider. Yeah, but for now, the easiest way is actually just I have the code here to delete all the component and just recreating the component again. So it will be easier. No need to consider the manual work. Okay, like this. So that's it for today. Let me know if you have any questions. If you are interested in this kind of the process, I can introduce more the script. If there's some things interested part, so for example, the delete is we need to delete the engineering connection first before you delete the instantiate part. So like that to avoid the error when you update. Thank you for watching.